Hi, this is Nikunj Ratnaparki. In this project, I have developed an application based on Java programming language, and this application provides a simulation of a web browser. So, what happens in typical client-server architecture is we have a server and a client. So, a client makes the request to the server, and then server processes the request, and based on the request, server returns some data or files to the client, which can so at client side, like users can visit those files, or they can get their request processed from the server. So to demonstrate this idea of client server architecture, I have created an application which provides a simulation of web browser. So what I have done is I have created the server using Java programming language and Java 2 standard edition, and I have coded a client as well using the same programming language. Then what I have done is I have created a directory of server, and I have placed one HTML file. Along with that, I have placed around 100 or 150 JPG image file on the server location. Then what I have done is whenever a client requests to the server, I have used socket programming to make the connection between client and server. So whenever client requests any data or any file from the server handles the request, server processes the request, and then send the HTML file to the client along with the data which is already there in the HTML file at the server's location. Now the biggest and substantial part of this application is, since I have used hundreds or nearly 150 of image files, so server process each image file independently, convert the image file into the byte stream, and then transfer the byte stream to the client. Then on the client side, what I have programmed is once the byte stream is received from the server, using the same byte stream, recreate the new image on the client location. So that way it provides a simulation of web browser. So now we have an HTML page downloaded on the client side. Along with that, we have hundreds or 150 images transferred from server to the client. And so now we have a connection between the HTML file and the images. So now we can say that we have simulated a web browsers in a similar way, that whenever we request any web page by typing the URL, so all the data of that corresponding to that URL is becomes visible to the client. So this is a kind of typical simulation of client server architecture using the web browser. So this is the project setup guide for non-persistent TCP connection, hands-on project. So to code to demonstrate this application, I have used non-persistent TCP connection. That means for every single image, for every single request, a client will create a socket, and then server will send the data using that socket. So, and then the connection will be closed. Then for the another image file, that means for another request, the same TCP connection will be established, and so on and so forth. So if you follow along this setup guide, then you will be able to easily replicate the same project and reproduce the same results on your machine as well. So so this is the first section is the introduction section. So I have pretty much explained this introduction section, where we are creating a simulation of a web browser, and we are creating a communication between the server and the client, and we are transferring the images from server to the client. So there are some prerequisites for this application to develop this project. So the first thing is I have used Windows 8.1, so I would recommend to go with that. And the second thing is I have used NetBeans IDE to program everything in Java programming language. So my version of NetBeans IDE is 8.0.2. So you can use any version higher than that, because I have used certain jar files which require the new edition of NetBeans IDE. So that's why I would recommend this version. So, and along with that, if you want to download NetBeans, you can just copy this link into your web browser, and this is the site of NetBeans, and you can download based. So I have used J2SE version, so you can download this for developing this application. Okay, so let's get started with there are a few requirements of this application. So the first and most important requirement for this application is connecting the application is importing the different kind of jar files which are required to execute our application. So this application has a lot of input-output operations. So the reason is we are reading few things from the file, and then we are writing few things into the file. We are creating the new file. Then we are using the input stream reader and writer to collect the data from the server and write to the new file. So Java has so like Apache Commons has developed a jar file which provides easy operations and which provides us the access to the static methods and properties which we can use in our application, which we can use in our code and make the application development very easy. So this is the site for downloading this jar file. So you can go to this site and you can download let this open. Yeah, if you scroll down, you can download this commons io dot 2 point slash 2.4 dot zar dot zip. There's like one jar file provided in this, so you can download and save it on your machine and unzip it so that we can later import in our application in the NetBeans. So all the instructions are mentioned here that you need to unzip this and then keep track of the folder with where you are saving the jar files. And this jar file comes with two main utility function which I have used in the application, which is the file manipulation path and general file manipulation. So since I have coded the application in such a way so that it runs on every single path or every single directory. So I had to make the path manipulation using the resolve path function and absolute path function. So a relative path function, I mean. So and that's why I have used this utility classes. The second main important Java library which I have used is JSoup 1.8.3. So JSoup is a Java library which works on the real-time HTML. So as I have mentioned previously that I have simulated the experience of web browser. So definitely, if we are simulating the web browser, then we have to parse the HTML page. So when we parse the HTML page, there are some image tags which I have used in my code. So I need to so every image tag is aligned has been assigned the name of actual JPG file. So to locate the name of that JPG file so that I can keep hold of that JPG file and parse that JPG file into the byte stream, I require this JSoup jar library. So this is a Java library which works on real-time HTML, real-world HTML files, and it extracts. I mean, it provides us an ability to manipulate the HTML DOM, and that is a HTML document object model, so that we can keep track of all the web elements and the CSS and the JavaScript which is already there in our HTML file. So to download this jar file, you can go to this link and well, I have provided the screenshots as well. So if you go to this link, this web page will gonna open and you can download the second one, source files, because this is lesson size. You don't require any Java documentation. If you require the Java doc as well, you can download the first one, which will come along with the source as well as Java doc for the file. So there are some key concepts like JSoup is a Java library for working with real-time HTML, and it provides manipulation to the DOM environment. So let's get started with the real coding for this application. So once you download the NetBeans and install the NetBeans on your machine, you will see this kind of icon. So you can see a lot of projects here. So you can just ignore this for now because I have already a lot of projects in my NetBeans. So what you need to do, click on File, click on New Projects, and click on Java Application, because since we are using Java 2 Standard Edition for developing this application, we can go with Java Application. Then I'll name this application as client server non-p demo. Okay, so if I click, so I don't need the main class for now because I'll create all the classes by myself. So I'll click finish. So it will take a moment and it will create a new project for us by that name. So let's see. Yeah, so here it is. So this is the client server non-p demo which I just created. So this, as you can see, that this project has nothing in the source packages. So the first and most important thing which we need to do is we need to install, we need to import the jar files which I just discussed, because since we have a lot of file manipulation, input, output reading, writing manipulations, and image parsing manipulations, so we need those couple of jar files. So first I require to download those jar files. So I have saved my jar files in this folder. So once you download the jar files from the like the URL which I had mentioned previously, so you can save your jar file anywhere you want. So I have saved a couple of jar files, which is commons, IO, and the JSoup in this directory. So it's always a okay. So okay, let's take understand it this way. So you know that the path of this jar file is something d spring 2016 and all those things. So what you can do is you can right click, go to properties, uh, go to libraries, and then click add jar and navigate to the same directory which I just shown. But there is a problem. So once you take this project, and if you later on decide to develop the execution file for this project, then you will be in we can be in trouble, that because since the location of jar file is in some other folder and this project is located in some different folder, so we'll be having trouble with final deployment of the project. So there is always a better way to do that. What you can do is right click and go to properties, copy this path, go to the explorer, and paste this path. So now this is the folder where this current project has been created. So what you can do is you can first copy the two jar files and paste it inside this folder. So now we have the couple of jar file placed in this folder of this project. But then there is another thing. We need to link the project with the jar file so that we can use the methods and properties defined in those jar libraries. So sorry, if I go to libraries and click on add jar or folder, I need to go back to find that project. So this is the project. Yeah, and these are the couple of jar files. So you can control select both of them, click open. So now you can see that both the jar files are loaded in our application. So once I click OK, so now this is saving the project. Now I can use the methods and properties defined in those jar files. So this is pretty much explained in these steps which I have given screenshot for. So how to create the application, how to see whether the blank project has been created, and then how to create how to import the jar file. So now there is another important part is creating the Java package and then creating the Java classes. So okay, so to start up with this project, what I can do is I can right click and create. So as per the object oriented programming concepts, all the classes should be inside a Java package. So this is the Java class. So I can create like few classes like my client. So this is my first class. This will act as a client. So okay, so there's a mistake here. So first I need to create a package. So to create a package, I can name the package as client server, and then I can create a class inside this package, which is let's say my client. Then after that, so you can see that this class has been created with the no body here. In the similar way, what I can do, I can create the class of my server. So these are two blank classes. So for ease of understanding in this video, what I would do is I have already created such classes in another project. So I will use the similar classes so that we can quickly walk through over those. So let me pause the video for a moment and copy and paste the files in this folder. Okay, so now you can see that this is the package which we created previously, and I have already placed six Java files which I had created previously. And so I'll go through the work of each single file in a moment so that we can understand what each file is doing. So the first file is myserver.java. So this is a server file where I have coded everything which will make a directory to run as a server. So what this server has, so if I go to the folder structure which I had created in my workspace is, so if I go to project, so this you can see that D Spring and this path is exactly the same path which I'm at right now, and this is pointing to the server folder which I have created here. So if you go inside the server folder, I have three files. One is index.html. So this is basically a server which client cannot see directly. So this is a server where we have index.html file. We have base file. So in this base file folders, I have a lot of images file. There are nearly 150 something images file there in this server, and along with that we have request information file. So this request information file contains the data of this indexed file, which will, so my code will make the get request to get the index.html page, and using the HTTP connection it will get the data of index.html page so that it can be ready, it can become ready to be sent to the client. So this is the basic structure of my directories. So okay, so the main thing is to initiate the server, first we require server socket listener. So server socket class is defined in this socket programming Java, which returns the server socket, which further listens for the client request. So whenever client makes the request, then only the program execution will go further. So initially the program execution will halt at one point, and that point is this one. So whenever I run the server, the program execution will going to halt at this point, and the program execution will remain halt until client makes a request to the server. So once client makes the request, it will go to the next step, which is client connected for a specific request. So let me just give you this much walkthrough for the server right now, so that we can able to understand how the connection, how the data is getting transmitted between the client and server. So there are a lot of programming there in the server. So I'll go through this after I explain how the client will make the request. So this is the client file which I have created. So client can be initiated by the given IP address which I am using as a local host, and at any given port number. So again, the client will read the data from the request information file, which has the data of index.html, which has the get request for index.html file. So what it will do is, I have created a socket factory class. So why I have created that? So the reason is since we have understood that the server has a server socket which is like a parent class of all the sockets. Now that server socket class will keep listening to the client till the point it listens for any request from the client. It will halt the execution. So for the client to initiate the request, we need another socket. So the socket of client can get in touch with the server socket, and they can communicate with each other. So for that I have created a server's factory class. Now this server factory class will do nothing but just it will create a new object of socket using the server IP address and the port number. Now another major important thing is, I have used port number in the server.java class and the client.java class. So we have to make sure that both the server and client listens to the same port, otherwise they won't be able to talk to each other. So okay, so we have understood the function of this socket factory class. That socket factory class returns a socket, a client specific socket, in an easy term to understand. So now once we make the client specific socket, this program execution will go further from this step. So since I have used a try and catch block, so even if we directly, I mean, if some execution exception occur, then it will go in the catch block and a program will not fail directly. So okay, so that part is done. So now our execution will go to this step. So right now the output stream writer. So there are like two major concepts: the input stream writer and the output stream writer. So I mean input stream and output stream. So what happen will, the client will pass the data to the output stream, and the server will read the data from the input stream. So in the next steps, so since we have already created a socket here, and so now, yeah. So since this step has been executed, now our execution will reach to this step. So it will create output stream writer, and it will look at, I mean, the server will look at the output stream of the server socket. So now, once server start looking at the output stream of the server socket, client will start processing. So what it will do is it will read the information from the request information file. It will parse the information using the the jar files which we have already used here in our project, and these couple of jar files. So it will parse the information. It will create a string writer. It will copy the information, and then it will convert all the data of this file, which is like index.html file information. I mean, it will get the index.html files information using the get request, and it will collect all the data in the string writer. It will convert the data into toString, so that all the response from the server can be converted to a string format, so that we can process it very easily. So once that part is done, it will create the output file in the cloud in the client directory. So as you can see here, in my directory path, I have one more folder which is client, and there is no output.html file right now. So what it will do is, so here I have done some string manipulations operations. So what I have done is, I have found the last index of slash server this, and then I have appended client dash client, so that I can reach inside the client directory, and then I have created output.html. So this will create a new file by the name output.html, and it will copy the data inside that file. So before going further, what will happen is, once the data has been transmitted using the output stream from client, the server will keep listening to its input stream. So here we are using get input stream. So once the input stream has been listened by, I mean, once the data has been received in the input stream, I have parsed data in name of file. I mean, it's a variable which I have created. So what I have done is, so if you check this request.information file in the server directory, in this request.information file, I have used get space, just remember the space, and then index.html. So what it will do is, it will read the whole line. This will read the whole line and split the line by spaces. So this will come at, and then once it do the splitting, it will save the data in this array of strings, which is data data coming from client. So the zeroth index, at zeroth index, we will get this word, which is get. Since we are doing split by space, at the first index, this index.html file will appear, which is, I mean, that is what we need for our further processing, to read the data from the index.html file. So next step is, it will check whether this file contains .html, which it definitely contains, yes. So it will go inside this for loop. So once it goes inside this for loop, it will start reading the data of which is there inside of this HTML file. And if there is no file exist, it will directly print that no file exists. And if there is some file exists, then we have used the buffer reader to read entire data inside the index.html file. So this will, okay, so first part of this application is done. It has read the HTML file from the server, and then in the client side, we can see that it has created a client folder and output.html, and transferred all the data from server to the client using this copy function of commons package and commons library, which we have used. Now this will, once that is done, it will close the connection. So this will close. And since we have used while loop, I mean do while loop, so again the execution will go inside the same loop, and now the thing is, it will start reading the data inside the HTML file. So again, this the same thing will happen. So this is my so since under my index.html file, if I open this file in let's say Notepad++, so I can see that it will take a while. So let's say if I open my index.html file in the Sublime text editor, so it will see that the first index of this file is base folder. So it will find the file inside the base files dot I mean base files folder. So in the base files I have all the uh, this different kind of files, JPG files. So if I go back again here, and so it will check whether the name of file contains JPG or JPG. So yes, we can see that this extension is JPG. So now the extension is JPG. It will go inside the base file, and it will start keeping track of each single file. It will it will read the image file, and then it will create a buffered image, which is the byte stream, which is the I mean this was one of the challenging part of this application. Now using the byte stream, it will write the image, and then it will flush the image towards the client. So once that is done, so client receive the byte stream of the images, and then once the byte stream of image is received from the server, I have created another method which is fetch images from the server. So now this fetch images from the server will make a get request for the byte stream, and then it will start parsing the image into element by element. So what it will do is, since we have received the data of index.html file, it will check the source attribute of the HTML file, and then using the source attribute, it will uh, render the it will get the byte stream from the server, and then using the get method, it will read the byte stream, and then it will start loading the image. I mean converting the byte stream into the image by using the image io.write function. So once that is done, it will return the number of TCP connection, which is one for every single image. So I have used the number of TCP connection plus equal to this. So every time it makes the call to this fetch images server method, it will increase the TCP connection by one. So these number of TCP connections should be equal to the number of images transferred from server to the client. So this is a typical example of non-persistent TCP connection. So I have pretty much explained what classes I have developed and used to get the things accomplished. So this is like a file reader class, and another which I have used to read the index files, which I'm calling from my client class. And then this is the image factory class, which I have already explained. Then this is the image parser class, which will not do much of the things, but I tried to make the code more modular. That's why I separated this class. So this will just find the images by tag, and then it will return the image to the image factory class. And then this is my client, this is my server, this is my server socket factory class, which will return the client specific socket. So now it's time to run the application and see the behavior, what happens. So what I have so now I have the port number in my server class and my same port. So now I'm pointing to 4488 port, and this is the same port I am pointing to from my client class, and I'm referring to the local host. So let's run the code. So first I have to run the server.java class. So once I run the server.java class, I can see that server is waiting. So my execution has been halted at this point. Not exactly this point, but at this point. But since I have returned this message here, so that's why it is showing on the output console. So my execution has been halted at this point. Now it will wait. My server will wait for the client to initiate the request. So now if I run the client, uh, okay, before that, you can see that this is my directory structure. My client doesn't have any output.html file, and there is nothing in the base files folder of the client. So if I run this client, you can see that this is the output console. This is printing some messages which I used for the debugging, and immediately the output.html file has been created, and the base file is getting populated continuously. So we have 78.jpg last, then 93. So it's coming. All the images from client is from server is downloading to the client, and it will, for every single image, it will create a socket and transfer the image. So now I think all the images has been transferred. So there are like 151 images here, items here, and 151 TCP connections has been established. That means 151 times this method of a client, this fetch images method from the server has been established. So this is like a typical client server architecture which has been established using non-persistent TCP connection. So everything is pretty much explained in this document. So if you want to reproduce the application at your machine, then I would suggest you, I would highly recommend you to follow every single step. And I have also attached the Java files which I had created in this application here. So you can just double click and save the Java files. Also the index file and request information.txt file is also attached with this document. So I'll read out a few lines of the results section that as per the steps and navigations mentioned in the document, we can interpret that for each transmission, one TCP connection has been established, that is non-persistent TCP. And using the socket programming in Java, we are able to program client and server, which interacts to simulate a traditional web browser. Programmatically, we have also learned about how to parse an image into a byte stream and recreate the image at the client's location. So this was a great learning experience for me to brush up my Java programming skills and work on some hands-on application using the Java 2 standard edition. So thank you so much for this opportunity.